Tomatoes are sprayed with a pesticide fertilizer mix. The figures below give the yield of tomatoes per bush for various spray concentrations. So we've got spray concentration, which is going to be the variable X, the independent variable. And the units of that is milliliters per 2 liters. So that's just the concentration. Then we've got some numbers. And the Y variable, the dependent variable, is yield of tomatoes per bush. So how many tomatoes you can take off each bush and eat them or sell them or whatever. So all we need to do, calculate the equation of the linear regression line using technology. So we're using technology to find the equation of a line of best fit, which if we plotted a scatter graph should look very good. So you need to be in stat mode. This is all statistics. So on the main menu, you need to go to statistics, the second one. And if you've got old lists in there, you need to delete those. So I've got some old data that I don't want. I'm going to just clear everything with the delete button. So then what you need to do, just the same as when we calculated the mean point, I need to put in the X values into list 1 and the Y values into list 2. So 2, 4, 6, 8, 10, and 12 in the X, and in the Y's we need 45, 76, 93, 105, 119, and 124. Remember, useful check. We've got 6 rows there, both match up, and there are 6 different points in the question. 6 X values, 6 Y values. So if you wanted to calculate the mean point, you would go to calc and to var, and you'd go in there and you'd say mean X was 7 and mean Y was 93.7. We haven't been asked for that for this bit. So what you need instead, you don't need 2 variable statistics for a mean point, you need this regression will tell you everything else. It will give you the equation of line of regression, and it will actually give you correlation statistics as well. So if I press F3 for reg, and I need to tell it what type of regression it is. This is just an X one because this is linear regression. It will always be linear regression for this sort of thing in the IGCSE. So we press F1 for X. And we do want it AX plus B. We want Y equals AX plus B. So then we get everything. So we have Y equals AX plus B. And it tells us A equals 7.657. So to 3 significant figures, which you should, unless prompted to do otherwise, that's how you should give it. A equals 7.66. And B, again, to 3 significant figures, B is 40.1. So the line of regression Y equals AX plus B must be Y equals 7.66 X plus 40.1. Right, I will just say one other thing. This R value here, which is a useful thing as well, that is actually a correlation coefficient. Now, it's not actually in the IGCSE, but it's a really, really useful number. What that tells you, because it's quite close to, it's positive, firstly it tells you a positive correlation. The maximum this thing can have is the value of 1. This is quite close to 0.9689666. It's quite close to 1. So this is actually telling you it's a strong positive correlation between the 2 variables, which is useful because it means that, well, firstly it means we can use our regression line, and secondly, well, it just supports the actual thing, the claim that you're going to make from looking at your scatter graph and saying that it's a good positive correlation.